Hello, my name is Russ Selzer, and I'm going to demonstrate to you the results of the everyday chemistry experiment entitled Polymer Synthesis and Organic Synthesis. In the first procedure in the experiment, we are going to make two ester compounds. Ester compounds are materials that are usually components of flavors and fragrances. And the two we are going to make today are oil of wintergreen and banana oil. So to make oil of wintergreen, we start off with 300 milliliters of boiling water to make a boiling water bath in which to heat our reactions. And we're going to take a 6-inch test tube and add a spatula full of salicylic acid, which is the first component, first reactant. And then we're going to add about 2 or 3 milliliters of methanol, so from a graduated cylinder, to the test tube. We're going to add a little bit of methanol, mix that together a little bit, and then finally the other reactant will be concentrated sulfuric acid, just 1 or 2 drops, and then that is mixed well, and we'll put that into the water bath to be heated. And while that is heating, we'll start the second part of the procedure. To prepare the second ester compound, we're going to take a few milliliters of isoamyl alcohol, 2 milliliters of isoamyl alcohol into a graduated cylinder. We're going to add that to another 6-inch test tube, and to that we're going to add the other reactant, which is glacial acetic acid. I'm going to put about 2 milliliters of that into the test tube, and once again 2 or 3 drops of concentrated sulfuric acid. Mix that around a bit and put that into the hot water bath. And those two reaction mixtures will heat up for about 5 or 10 minutes. So it's been about 10 minutes in the hot water bath. It is hot. And let's make some observations, in this case observing using the sense of smell. So this first test tube does smell like oil of wintergreen. Here, give it a whiff. And the second test tube, a little bit warm still, certainly smells like banana. So we've made oil of wintergreen and banana oil. So those would be the two observations that you would put down for part 1 of the experiment. So the first polymer we're going to prepare is slime gel, which is a polymer containing polyvinyl alcohol. So I'm going to take some polyvinyl alcohol, actually 10 milliliters of polyvinyl alcohol, that has been dyed green with a food dye. And I'm choosing green because I'm making this video on St. Patrick's Day in 2020. So 10 milliliters of polyvinyl alcohol into a small beaker. And to that we're going to add about 1 to 2 milliliters of sodium borate solution. Sodium borate solution is better known as borax, used as a cleaning agent for clothes in detergents. Simply going to add that to our polyvinyl alcohol solution and stir it up very well. And after a little bit of stirring, almost immediately we have made slime. And that certainly is slimy, as you can see. And it's green slime, which makes it even more unattractive to the touch. And in fact, it is safe enough to touch. And this is a polymer that's known as slime gel, polyvinyl alcohol and sodium borate. Second polymer that we're going to prepare is a rubbery fiber. And to do that, we again are starting with our green polyvinyl alcohol. This time we'll take maybe 3 or 4 milliliters of that and add it to a beaker. And then we're going to add some acetone, which will, again, cross-link this polymer. Just squeeze a little bit of acetone in, and what one can start to see in the bottom of the beaker is a white rubbery substance being formed. And we'll just stir that around a little bit, and we'll take it out of the beaker. And then we can pick it up. I will pick it up, and its property is that it is a stretchy polymer. I could stretch it out to a limited extent. At some point it will break, but this part of the experiment was meant to illustrate that we can make polymers of many, many different origins and properties. This one happens to be an elastic polymer, also known as an elastomer, such as in a rubber band or a nylon piece of fiber, etc. It's a stretchy polymer. So the observation for this part of the experiment is stretchy fiber. And that completes this experiment.